I'm very happy to be with you all here today and to show you Ask Swimm. And what I'm going to do in the beginning is show you how I used Ask Swimm to contribute to a code base that I had never contributed to before, specifically an open source version of a game that I'll show in a moment. And then I'll talk a bit about how it's actually implemented. So the game I'm going to show today is called OpenTTD. TTD stands for Transport Tycoon Deluxe. You might recognize this game. It was released in 1995, and the open source community shared an open source version of it. And in this game, players build transportation empires by building roads and train stations, airports, and stuff like that. Now, when I was playing it, one thing that really bugged me, I tried to build this huge train station, so I had to remove some roads, and then I got to this error. So I got a message telling me I can't clear this area because the local authority refused to allow it, which is, well, annoying. I really wanted to build this train station. So I thought, okay, I might just use a cheat. Games have cheats, and OpenTTD has cheats. If you open from the UI, you find the cheats pane and you see different cheats that are available, like increasing money or changing the date and other things. But I didn't find anything that was applicable to my use case. So I thought, okay, it's open source. Let's just change the game. And for that, I would need to understand how to add a new cheat. So I started by asking this to another chat application that is not Ask Swimm, that doesn't actually know the entire code base. So when I asked how to add a new cheat type to the game, the response I got wasn't incorrect. It was just very generic. He told me that as an AI programming assistant, I can guide you on how to add a new cheat type to a game in a general sense. However, the exact implementation will depend on the game's architecture and the programming language used, which is correct and exactly what I need. I need specific instructions on how to do it in this game. So now I'm going to head over to Ask Swimm and ask the same question. So when we ask Swimm that, and before I show you what I get, just to understand that actually what I'm asking here is how do I add a new occurrence of a recurring pattern in the code base, something that is very common when you introduce changes to a code base. So to really answer that question, Ask Swimm will have to understand what a cheat is and how you add a new one, that is what different occurrences of cheats have in common and generalize upon that. And this is exactly what I'm going to show you now. So Ask Swimm tells me that it involves a step-by-step guide in this case, and it shows me a few different files where I need to make changes. One of them is cheattype.h, and there is this struct here. I called my cheat sudo remove, and now I have to add it in another file called cheat.gui for the graphical user interface, where I have to add this as well. And there are other structures I need to update. I won't trouble you with all the details of implementation, but Swimm took me through a walkthrough of the code base here, specifically two different files that I needed to change in order to add this to the UI. So now we can test our changes. I can rebuild or recompile the game using make. So I'm building it. I'm going to launch the game again. And in the cheat pane, I have a new checkbox called sudo remove roads everywhere. And I can select the checkbox, which is great, but it's just a checkbox. It doesn't do anything. I mean, I can read the value of it and understand whether it's selected or not, but that's all it does. In order to really understand how to implement this cheat, we need to understand how or where the block is implemented, how the game knows to block a user from removing a road in town. So I will ask Swimm again, and this time, notice that it's a different kind of question. The previous question got Ask Swimm to look in the code base, find different occurrences of something, specifically cheats, and then generalizing on what adding a cheat means. In this question, on the other hand, we're asking about a very specific behavior and location, and Swimm basically needs to point me in the right direction and maybe explain a bit. So here, when I ask where do we check if a user is allowed, oh, I had a typo there, never mind, to remove a road. Then we see here that we get to a specific file, and Swimm explained that this is the function check allow removed road in the file road.cmd.cpp that checks if it's allowed to remove the given road bit from the given tile. Again, without diving too much into the specifics of this game, we can see that there are a few checks here that decide whether I'm allowed to build or removes specific things, specific road bits, and also computes a cost for it. Specifically, we can see on line 279 that there is a check. And if we don't do this check, if not sound check, then we return command cost. So I'm just going to implement the same thing. I'll say that if my cheat is set, then return the command cost. After I implemented that, and I check the box, I can remove all the relevant roads and implement my desired new train station. Hooray! Okay, so that was fun. Now what? So let's consider that I implemented a change to the game, and now another user, another developer sometime wants to understand this cheat. So if you go back to Ask Swimm at this point and you reanalyze the code base, and you pose a question like, what does the sudo remove cheat do? Swimm is able to analyze the code and explain the addition that I just made. The sudo remove cheat in OpenTTD allows you to remove town roads even if the town reputation is low. It goes on to explain why you would sometimes need a reputation with a town to perform certain actions, but again, irrelevant for this demonstration. You will also notice that at the bottom here, you see that Swimm suggests some follow-up questions. So you might want to ask, how can I activate the sudo remove cheat? Or what are the other cheats available in OpenTTD? You can click on them and get the next answers. So this is a simple question. And now I want to actually document what I did in implementing this feature and also include some things that are not implemented in this document. So to start, I could write a document manually, but using Ask Swimm, I can ask a question and let Swimm do the heavy lifting for me. So I'm asking, how did we implement the sudo remove cheat? And I'm going to get a response that is an answer to the question, which actually serves as a good basis for a document. It explains what the cheat is and how it's implemented in the UI and also in the backend. And now if I click create doc, then Swimm takes this and creates a basis for a document from the conversation I had with Ask Swimm. At this point, we also suggest that you couple some of the elements with code. So for example, the document here, which used to be the answer of Ask Swimm, begins with the sudo remove cheat, and you might want to link this to code. So the name sudo remove is the name of the cheat. If it ever changes, we would want it to change in the document as well. So Swimm suggests that I couple this, that I link it to a specific token in the code. For example, sudo remove from line 197 in the file cheat gui.cpp. Or I can pick the one on roadcmd.cpp. So I'm selecting the one that I want, and now it's coupled with code. If that name ever changes, we'll change it in this document. If it's ever removed, we'll notify you that this document needs updating. We can do the same for paths. Like here, we have the file chat.gui.cpp. If this file is ever renamed or if it's moved to another directory, we would update the document so it stays up to date. The same applies, of course, for the code snippets you see here. So all of the lines, for example, from cheat.gui.cpp. So after all of the explanation I got from Ask Swimm, and this is the part that we implemented before with that if the cheat is set, then return command cost, I wanted to add something else. While implementing this cheat, I actually wanted to avoid blocking the user not only from building roads or removing roads, but also from removing industries. And I ran into a bug when I tried to implement it, and this is why I didn't implement it in the end. Now, I wanted the next developer to look at this document, say a developer who wants to extend this cheat, understand why I didn't do it. Obviously, it's not something you can understand from code because it's not implemented in the code. I ended up not implementing it. So I added an explanation. I said, okay, let's explain why we didn't allow users to remove industries. So I explained here that we found that if an industry in a town is being removed, it can cause an error in the path finding algorithm relevant to the adjacent station, which is one of the more complex parts of this code base. And I didn't really have the motivation to debug it because, frankly, I just wanted to remove those roads and build a train station. I will deal with industries if I ever face that challenge. But now, if another user, another developer gets to this repository and is curious about this specific detail, or if I reanalyze the codebase with Ask Swimm, I could then pose the question why the sudo remove cheat does not allow to remove industries. And I get a response that is based on the code of industries, but also this part of the document that explains and it says the document, how did we implement the pseudo remove cheat, provides some context on why industries cannot be removed using the pseudo remove cheat. If I click, it opens up the document on the right-hand side. So this was a brief demo of what Ask Swimm looks like. And as you've noticed, we actually asked different type of questions. We asked how to add something, with how something is implemented or where something is implemented. We asked what a cheat is, a specific cheat, with why something is not implemented in this case. And in all of these various scenarios, Ask had to understand the code base in order to provide good answers. So now I'm going to briefly describe what's happening under the hood of this capability. So basically, when you start with Ask Swimm, you're a user, you're posing a question, and Ask Swimm wants to find an answer and provide you with an answer. Now, the key to understand here is that when we get the question, our goal is to find all the relevant context. And in this case, it could mean, for example, for the question of how to add a new cheat type, it means finding different examples of cheats, or maybe even going further and explaining about those cheats, what's common for them among different cheats. And then we provide all of that information as context alongside the original question to a large language model such as GPT. Then the LLM, the large language model, gets the question and the context and generates the answer, which we then provide the user. So it's all about the context. This is the important thing to say here. Obviously, we're relying on LLMs, magnificent technology, but the missing part for LLMs without Ask Swimm, say, is the context, the knowledge of your code base. And we found in many different trials and errors that if you provide too little context, obviously the LLM can provide a full answer because it doesn't know what context it doesn't receive. On the other hand, if you provide too much context, the LLM also does a pretty poor job. So if I were able in a futuristic LLM to provide all of the code base as context, it would be slow and expensive, but also it seems that LLMs are pretty poor at doing a job. They do a pretty poor job when answering a specific question from a very large context. I like to think of it as if you were given a book. I would ask you to read through it, all of it, and then ask you a specific question whose answer resides on a random page in the middle. So our job at Ask Swimm is to provide the model with all the context it needs, but hopefully only the context it needs. So how do we do that? Basically, we rely on two main sources. One is your code base, and another is documents. When I say documents, I mean both Swimm documents as well as existing documents on your code base, like README files or other Markdown files or TXT files, and so on. We take your code base and we perform deep static analysis. So in this stage, we understand a lot of things about your code base. For example, what functions there are, what classes there are, who is calling who, so different relationships, the file structure, and other things. We then do a bunch of things here. One is to create entities. For example, this is a function, this is a call, something like that. And the other is to use something we built in the past and revived now for Ask Swimm that we call Swimm generated docs. These are full documents that look just like the Swimm documents I showed you before. So they include text alongside code snippets and tokens, so elements from the code. And they actually explain a concept about the code base with code and text to the LLM. We found out that this is actually the ideal input for LLMs. I think that because LLMs were trained mainly on natural language and natural language alongside code, then it makes sense that the ideal input for LLMs would be code alongside text that describes it. Also, it's much easier for an LLM or a developer, to be honest, to understand complex code when you actually show the different parts of the code of the specific flow alongside explanations in natural language, rather than just send a lot of code. So we take bits taken from static analysis, as well as the Swimm generated docs, and also documents that were created by users, and we create knowledge items from all of them. So this is our knowledge base. It consists of knowledge items, which we then pre-process and store in a vector database. We then optimize the vector database so that when someone asks a question, we can retrieve the relevant knowledge items. And this needs to happen very fast. So a lot of optimization is happening in the background to make sure the retrieval process is fast. And of course, all of this can happen thanks to Autosync, our algorithm and technology that allows you to keep documents up to date as the code changes. So when you send the LLM with context, if you send something that is wrong or outdated, the LLM doesn't know that it's wrong, right? It trusts you that you send true data as context. So if you send wrong, outdated information, it's even worse than not sending information at all, because the LLM might hallucinate, or in this case, rely on actual data that is wrong that you send them and write something misleading. So by using Autosync and by rerunning this process in a smart manner upon code changes, we make sure that we feed the LLM only with relevant context that is up to date with the current state of your code base. So to zoom out again for the big picture, when a user asks a question, we have this knowledge base we've built, and we put a lot of energy into building in an effective manner, so that when a user then asks a question, we retrieve all the relevant knowledge items from the knowledge base. We might then also enrich those items on just-in-time manner, given the specific question, and then we provide all of the context that we found. Again, we're striving to give all the relevant context, but only the relevant context as a message to the LLM with the original question, and then the LLM generates an answer, which we provide back to the user.